Hello everyone, my name is Anindya Dasantar and I am a PhD candidate in the Computer Science and Engineering Department at the University of Michigan. Today I am going to present our work on VIME, Visual Interactive Model Explorer, for identifying the capabilities and limitations of machine learning models for sequential decision making. I would argue that to investigate the capabilities and limitations of machine learning models is necessary for their broader adoption into high-stake decision-making scenarios. And that's why we already have many existing explainable AI tools that help ML engineers to investigate the capabilities and limitations of classification models that make single-point estimate predictions for each data point. Also, there are toolboxes such as Google's What If tool that combines multiple XAI tools into a single software. However, most existing feature attribution methods are not designed to support sequential ML models because it's challenging to evaluate long sequences of model decisions. Although a few existing XAI tools can help visualize sequences, they may not generalize across ML models or handle long sequences. So in this talk, I will present a design that explores this key idea that decomposing long sequences of model decisions into smaller what-if scenarios help users to develop their mental models to form and leverage explanations and also make sophisticated high-level decisions about sequential model capabilities and limitations. So with this key insight, we iteratively designed VIME, an XAI toolbox to investigate sequential decision-making ML models. Our evaluation of this tool showed that interactions in VIME made it easier for users to define their own rules for decomposing long sequences into simple what-if scenarios, identify instances where the model made wrong decisions, and investigate what caused them. Since I have already introduced the challenges of evaluating sequential ML models, now I will describe how we have designed the VIME toolbox. So we designed VIME with model engineers in mind since they are the first in line to develop and investigate their ML models. We reviewed existing literature, including review papers on interactive ML debugging and explainable AI to document ML engineers' needs when investigating trained ML models. Note that model engineers work with different types of models that are often built on cross-sectional, time series, or pool data that combines both data types. Also, these types of data can come from various domains and tasks, making it particularly important to have tools that are both domain and task agnostic. Moreover, they often investigate these models at different levels of granularity. At the global level, they may want to evaluate the overall model strengths and limitation. Also, they may want to explore how this model performs for specific cohort or subgroups of data, and even for local individual instances. To achieve this, we found this key design that effectively decomposing complex sequences into simple and relevant what-if scenario can help evaluate model decisions at different levels of granularity. Therefore, to design a toolbox that addresses these user needs, we followed an iterative design process, progressing from low to high fidelity prototype. Now, I am going to show you a live demo of the final high fidelity VIME prototype. But before I demo VIME, I want to introduce an illustrating example. Suppose that I am an ML engineer who is interested in evaluating an existing off-the-shelf generative sequential model trained on an existing driving dataset to predict aggressive driving behavior at the intersection. However, the challenge with evaluating the driving model is that the model is quite large with many features that are either time-independent or could be time-dependent in nature. So, I have chosen a simple what-if scenario that is well documented in driving literature, and some of you may have also experienced this while driving. It's that aggressive drivers rushing straight through an intersection with yellow traffic lights are more likely to get stuck in the middle of the intersection before exiting, potentially blocking the oncoming traffic. But before using the model, I want to ensure that the model is making accurate predictions while capturing meaningful relations in the data. So now let's jump into the live demo and fingers crossed that it doesn't fall victim to the UIST demo curse. Okay. So, first I want to look at the maneuver of how those drivers are driving through the intersection with different traffic signs. I'm also interested to look at the current speed and whether any changes in speed influences the model decisions to predict aggressive versus non-aggressive drivers represented by this outcome feature, existing traffic violation. VIME then uses interactive sun visualization to display sequences from both the data and model using two separate tabs. Next, I want to investigate whether the model has captured that speeding while entering the intersection leads drivers to stop while they exit. So thus, instead of looking at all four different positions in the intersection, I can zoom in to observe car speed when they were entering and exiting the intersection. I can also use the group-ungroup feature value interaction to cluster all speed values when the drivers were exiting the intersection. And now the sun visualization will allow me to compare those sequences where the driver stopped versus did not stop while exiting the intersection. Now, such kind of stopping could be a common behavior when the drivers were taking left or right turns or while approaching a stop sign. So, I can use this filter tool and click on the straight node to only isolate sequences where the drivers were going straight through the intersection. And similarly, I can filter those specific intersections with traffic lights because aggressive drivers are more likely to stop after rushing through a yellow light. And now, we can hover over this node and observe that although such stopping behavior is not very common, occurring only 5% of the time, but when this does occur, the model predicts around with 91% probability that this could be characteristics of aggressive driving behavior. However, I am noticing something odd here. There is a connection that shows that these drivers can enter the intersection at over 50 miles per hour and suddenly stop while exiting with 6% chance that is physically impossible, indicating model's tendency towards overgeneralization. To investigate further why this happens, I can switch to the data tab and observe that such connections don't even exist in the actual driving dataset. This shows that while such generative sequential model can correctly predict the outcome, these models also have the tendency to overgeneralize to physically impossible situations, likely due to missing or underrepresented data. Now that I have shown you how the VIME tool works, I will also show you how other ML engineers have investigated this tool. So we evaluated VIME with model engineers through simplified user testing using a think-aloud protocol. During evaluation, participants had to explore either the driving sequential model to predict aggressive driving or the multiple sclerosis model to forecast end-of-day functioning. We used Google What If tool as the baseline toolbox since it contains different tools that support what if scenario exploration. And we also improved the What If tool functionalities to support sequential model evaluation similar to an existing XAI tool named TimeShap. For the user study, we recruited 14 participants with prior expertise in ML and asked them to complete two tasks. In task 1, they evaluated a prescribed what if scenario using both VIME and UIST, where the driving scenario I already showed you in the live demo. And for the MS model, participants had to create a scenario where people with MS started their day feeling high fatigue. And for task 2, participants had to choose and evaluate what-if scenarios on their own with their preferred tool, either VIME or WIT. Then we close-coded participants' think aloud data based on the user needs and design goals that we highlighted. We then qualitatively analyzed if and to what extent VIME and WIT address those user needs. Our evaluation results showed that interactions in VIME were more effective than the what-if tool to evaluate sequential ML model decisions at each time step. For example, the what-if tool limited participants to visualizing only 2 features at a time. They had to first evaluate the relationship between exiting speed and maneuver, and then between exiting speed and traffic signs to explore the driving scenario, unlike VIME that offered easy feature selection and filtering. We also found that VIME made it easier for participants to create global and cohort-level what-if scenarios, while what-if tool was more helpful at investigating local or individual sequences. For example, using the what-if tool, participants could click on individual cells of the flow chart to see explanations for that single sequence on the left-hand side panel for further investigation. Moreover, out of 14 participants, 12 chose VIME for the final task, showing their preference towards VIME for sequential model evaluation. So in summary, we present VIME, a data, domain, and model-agnostic toolbox to investigate sequential ML models, and our findings showed that a series of interactions in VIME helped model engineers decompose long sequences into smaller what-if scenarios that, when combined, could aid in comprehensive model evaluation and help debug model errors and limitations. In this work, we focused on model engineers, but note that there are also other end users, such as domain experts, policymakers, and consumers, who may not have computer science-savvy expertise. We are currently evaluating VIME with other domain experts who have data analytical skills. Additionally, we are considering how to design better tools and make them accessible to policymakers and consumers, although this is extremely challenging. And with this work, we are hoping that it will bring us a step closer to enable a broader set of stakeholders to investigate the capabilities and limitations of diverse machine learning models. Thank you, and please feel free to ask any question.
Thanks for your very insightful and exciting work. And I have one question. Like, you're implemented the knowledge-based AI or like rule-based knowledge there, and I think there's one challenge is that how do you make this this knowledge or rule like generalizable for other scenarios? Like you showed in the data in the evaluation part that there's like another scenario. Like how do you generate those rules for that scenario, and how does that implement in other like specific scenario?
That's a really great question, and we also actually face the same problem when we were exploring the tool on our own, because we knew how to operate the tool, but we didn't have that much great idea about the driving domain or the multiple sclerosis domain, since this is a domain agnostic tool. And what we did is we consulted with researchers who work on this domain and also some domain experts like clinicians. And through that consultation, we came out, we found these interesting scenarios that they are interested in while investigating these models. And they also told us that they not only are interested to know how accurate this kind of models are, but also they are interested to know how well this kind of model will perform in those real-world scenarios. So I think that's a thing that we still need to solve, that in one side we have the model developers who knows about the tool but doesn't know about the domain that much. And on the other hand, we have these domain experts who knows about the domain but not that much about this computer science heavy tool. So I think we still need to bridge this gap.
Okay. Thanks so much.
Thank you.